Hey, quantitative reasoning, welcome back. Today we are on 1-2 estimation with rounding and decimals, fractions, percent. All right, so we're just going to refresh everybody's memory on what you call each of the place values. So when I say round it to the nearest tens or round it to the nearest hundredths, you remember what to look for. So this is where the decimal is, and that's where I drew my dotted line. And so I'm going to turn it here. There we go. So recall that this first digit to the left is the ones place, and the next one is the tens, the hundreds, the thousands, and the 10,000s. And then when you go to the other side, to the right of the decimal, this first one here is the tenths. I did not have a lisp. I really ended it in THS. Please recall that everything to the right will end in a THS. The next one is the hundredths and thousandths. There we go. All to the right and in THS. All right, so we would like to find the tens place, so that would be the 3 right there. Find the hundredths place, that's 2 over, that would be a 2. And now we're going to round. So we have rounding. Rounding is to alter a number to one less exact but more convenient for calculations. So this one says round to the nearest 100. All right, so here is the 100 where the 7 is. Please recall that you look to the right of that, and we have an 8. So an 8 will round that 7 up. And so this is 4,800. This says round to the nearest tenth. All right, so tenth is where the 2 is. You look to the right, and that's a 4. And so 4 or less means that number stays the same, and that is 8.2. Any number to the right of the decimal, if it's a 0, is really just a placeholder. This has no, it doesn't change the number in any way, shape, or form. So if you add more zeros, this is exactly the same. So rounding is to alter a number for convenience. Estimation is a rough calculation of the value, quantity, or extent of something. So sometimes we would like to estimate someone's salary, or we would like to estimate the cost of something, and we don't want to pull out our calculator. We just kind of want to do a rough estimate. So Joe works full-time, making $28 an hour. Estimate his weekly salary. All right, so if he makes $28 an hour, I would probably round to 30 for estimation purposes. And if he works full-time implies that he works 40 hours a week. So to estimate his weekly salary, I would take $30 an hour times 40 hours. 3 times 4 is 12. Tag on the 2 zeros, and he makes $1,200 a week. And once more, this is just an estimate, not his exact. He makes less than that because we increased his salary by $2 an hour. Estimate his annual salary. All right, so you have to recall that there are 52 weeks in a year. And I might round and estimate that to 50 weeks so that I could get so I could do it faster. So if I make $1,200 a week times 50 weeks, 5 times 12 is 60, and tag on 3 zeros. So he makes about $60,000 a year is how I would estimate that. We would like to be able to move between percents, decimals, and fractions fluently. All right, so we're going to take our percent, we're going to change it to a decimal, and then we're going to change it to a fraction. So if I want to go from a percent to a decimal, you just move the decimal 2 places to the left, and that's the same thing as 0.12. So percent to decimal means move it 2 to the left. When you have a fraction is, you can take the percent divided by 100, because percent literally means per 100. So if I come back here and I focus on the 12, that means that I have 12 out of 100. And then when you probably want to reduce it, so that's how I get 3/25. All right, so 7.25%, we're going to move it 2 to the left again. When I move it 2 to the left, I have this empty blank here, so I'm going to have to fill that with a placeholder 0. So that is 0.0725. If you want to change this fraction to, or this percent to a fraction, so you have 7.25 divided by 100. And this, quite frankly, I did put in the calculator. It is not okay to have decimals in a fraction. So my calculator said that this is the same as 29 over 400. All right, so now we're starting with the decimal, and now I need the percent and the fraction. So I'm going to do the percent first. So we go the other way. So if you have a decimal, we're going to move it 2 to the right to come up with a percent. So 0.25 is the same as 25%. So therefore, when I go from a decimal to a percent, we're going to move it to the right. Same thing here. 0.035, I go 2 to the right. So now it's in between the 3 and the 5. So I have 3.5%. So once I have the percent, I can write it as a fraction. So 25 100ths, and we know that that reduces to 1/4. 3.5 divided by 100, I divided that in my calculator, and that is 7 200ths. All right, so here's some easy mental math. If someone says something convert 10%, all you have to do is move the decimal once to the left. So if I have 10% of 15, so your decimal is implied to be here at the end of the 15. If you just move it 1 to the left, you get 1.5. If somebody says calculate 5% of something, so if we use this same one, so 5% of 15. So it says find the 10% number and then divide it by 2. So I have 1.5, and if you take 1.5 divided by 2, you get 0.75. How do you know this? Because half of $1.50 is 75 cents. If someone says calculate 20% of something, find your 10% number and then multiply it by 2. All right, so if you take 20% of 15, so find your 10% number. So I have 1.5 times 2. So $1.50 and $1.50 is $3. So that's 3. If you want 1% of something, it says move the decimal twice to the left. So if you want 1% of 15, so your decimal is implied to be here, and then when you go 2 to the left, that means that 1% of 15 is 15 cents. So that's how you can work on doing some mental math. 15% of the students are likely to need extra help with their numeracy each year. Given there are 360 students in the school, how many students are likely to need extra help? So this says 15% of the students. Well, we know that there are 360 students in this school. Of means multiply in math. So this says basically take 15% of 360. All right, so anytime you have percents, you need to change them into a decimal. So that is 0.15. Of means multiply. So I'm going to take 0.15 times 360 and get 54. We could do this mental math, but we're going to keep going and just do it the exact way. At Kohl's, there are 2 signs for under a shirt for $35. One is for a 4th off, another is for 30% off. Are they representing the same discount? All right, so is a 4th the same as 30%? Well, no, because we saw up there that a 4th is the same thing as 0.25, which is the same thing as 25%. So they're definitely not the same. Which one would be better? Would I rather have 20% off or 30% off? Well, hopefully we all know that we would definitely want the 30% to win. That will get us the better deal. Which one would be better? How much would you pay in each instance? Okay, so if you have a 4th off, all right, so we are going to work on our mental math a little bit. If you have a 4th off of something, that means you're going to pay for the remainder, and that means you're going to pay for 1/4 of it, or 3/4 of it, I mean. So if you take the cost of this shirt, $35, and you multiply it by 3/4, the amount that you're going to pay, I stuck this in my calculator, and I got $26.25 is how much you would pay for the shirt. If something is 30% off, all right, so there is a total of 100% of anything. So if it's 30% off, that means that you are paying for 70% of the shirt. So we just learned that 70% is 0.7 as a decimal. So if you take the $35 shirt times 0.7, the amount that you're going to pay, this shirt costs $24.50. So this is basically how I go around the sales rack at Kohl's and go, how much is something going to cost? So if it's on the 30% off rack, I I know that I'm going to pay 70%, and so like 7 times 35, and then I adjust the decimal. And so this one is the better deal. All right, so let's talk about stocks for a minute. Last year, my favorite stock was worth $25 a share. Today, it is worth 104% of last year's value. All right, so a minute ago, we said that 100% is the most. So if you have 104% of something, that means it is going to be more than $25. So it's going to be $25 plus a little bit more than that. So if you take this and you change it to a decimal, 104% is a decimal, so it starts at the end of the 4, you move it 2 to the left, and you get 1.04 as a decimal. It is worth 104% of means multiply, last year's value, which we just said is $25. All right, so calculate the value of the stock. So if you take 1.04 times 25, you get $26. So now my favorite stock is worth $26 because it is worth more than last year's value. All right, let's do a restaurant tip. So we go to dinner, we leave our phones in the car so that we can talk. Maddie paid the entire bill, but she has to calculate the tip. She says, Chris, I think we should tip 17%. The service was good but not great. Do it quick, I want to go home. So if let's see, down here, I see the bill. It's off the screen, but the bill is $116.58 when you look to the left down there. And she wants to tip 17% of that. So if you want to tip 17%, I'm going to change this to a decimal, and that is 0.17. So your tip is, when I multiply these two together, 19.8186. Money is only 2 places, so if you look at the 1 and then you look to the right, that 8 will round this 1 up to a 2, so your tip is $19.82. So your total bill is going to be the tip plus the original bill. So I have $19.82 plus $116.58. Obviously not the short version like she wanted to do, but a very accurate one. And so the grand total is $136.40. All right, so when you tip, you have to pay the original bill plus however much you want to do that. So if you know that your bill is going to go up 17%, that would be the same thing as paying 117% of your original amount, or this $116.58. So if you have 117% of something, convert it to a decimal. So at the end of the 7, it goes back 2 places. That's the same thing as 1.17. So if you take your bill, 116.58, and you multiply it by 1.17, you get 136.40, which is the exact same thing that you got here. So if you know that your bill is going to go up you can basically just add a 1 to whatever you want to tip there, and then you don't have to calculate the tip and then add. It saves a step. So this is a fun fact. We can also estimate with graphs. So we have, let's see, what does this even represent? This represents 229 million Americans, 20 and older. What number of Americans think old age is a decline in physical ability? So I think that they took a poll and they were like, what represents old age to you? So 41% said decline in physical ability, 32% said decline in mental functioning, 14% said reaching a specific age, 9% said when they retire, 3% said becoming a grandparent, 1% said I don't know. All right, so can you estimate and draw a pie chart? Do you know what 41% would look like on a pie chart? So like, okay, so it's more than 25% of it, so 25% would be right there. It's less than 50%, so 50% would be half the graph. So it's somewhere in between 25% and 50%. Like, well, this is still kind of tough. I don't know. I'm actually going to jump, and I'm going to start here at the 32% one. 32% would be more like halfway in between 25 and 50. So, and I've seen a third on a pie graph before. So if you like did that and then kind of make the peace sign, like that is that's what it would take to cut it into thirds. So we're going to call this, so here's A, we're going to call this B, the 32% of decline of mental functioning. All right, so that's 32%. And that would have been 50%. All right, so the 40% is a little bit more than that. So here's the 25, like here's, so if I like just kind of go this way instead, there's 25%, there's 30%, there's 50%. So 40, I'm going to estimate, and I'm going to put it right about there, somewhere in between having 30% and 50% of something. So I'm going to call this A, and that's my 41% section. All right, so that adds up to like 73. So if you kind of estimate, you have about 25% here left right here. All right, so 14%, so that's 14%, and then all these numbers add up to 13%. So between reaching a specific age and all these other three, that's going to be about half of it. So if you kind of estimate and go, that's about half. I'm going to call that one C, so that represents my 14%. All right, so this is supposed to be the other like 14% or so. You need the biggest chunk to be 9%, and so here I would just kind of estimate. And then you need a little slice of a 3% and a little slice of a 1%. So I'd call that 1%, and that one 3%, and then that's my 9%. So you have D, E, and F. That was D, that was E, and that was F. So that's kind of a crude calculation of how you would manually draw a pie chart given some percents. What percent think old age is a decline in physical ability? Let's see, 41% do, so that's the number I'm after. And so in order to calculate this, you multiply these two numbers. So I'm going to take 2 to 9 937,770. 41% is 0.41 as a decimal. And when you multiply that, you get 94,207. No, hold on a second. Hundreds, thousands, millions. 94,274,485. Use rounding to find a reasonable estimate. All right, so 41%, I would probably round to 40%. And if you have 229 million people, I would probably round that to 230 million. And so I'm going to multiply these two numbers. I'm going to take 0.4 times 230. And when I do that, I get 92. But I dropped off all the zeros, so you would at least need to add the word million back into it. And looks like that's all. Try the homework. Thanks.